Hello, and welcome to the SRND session on RESTful APIs. My name is Jason Panzer. I'm an iOS engineer at Nordstrom and a sometime volunteer for SRND. And I want to talk a little bit about the way that we communicate with web services. This is not, none of this is the only way to do that, but it's some of the things that I have found useful and that the industry uses as a standard for creating meaningful communication between clients, like web clients or mobile clients, and web services. And these are important because two different software components have to communicate, and they can't communicate well unless there's a standard or a contract for doing so. This also helps teams work together. If I am making the Nordstrom iOS app reach out to a team that puts together different outfits for clients, I need to know where to go and how to request a resource, and they in turn need to know that I'm going to give them the information that they require to do so. So let's start with what an API is, because, and this was true of me as well for a long time, when I heard API, I thought web service. I thought this is what I communicate with when my browser tries to go to a particular resource and retrieve information. But it's not that straightforward. APIs actually refer to any programming interface for an application or for a software component. It is the set of methods and messages that that particular software system exposes to the rest of the world, whether that's other components or, in the case of what we're talking about today, a web service exposing different methods and different resources to a client. So this is one example of an API. You find them with SDKs, software development kits. You find them with other software components if you're using something baked in off the shelf. Um, What makes an API RESTful then, and RESTful is particularly useful for web services. Um, RESTful stands for Representative State Transfer, and it carries with it a number of different strictures, requirements. There are, I think, about seven all told. We're going to concern ourselves with three today because they're the for web services, the critical components. The the RESTful API must involve a client and server relationship. It must be stateless, and it must have a uniform interface. Client server, in this case, means I am, as a client, a web client, a mobile app, reaching out to some authority, in this case, the web service, and I don't need to know anything about the architecture of that web service. And that part's crucial. All I need to know is what that interface is, and I don't particularly care whether it's stored in a NoSQL database, if it is being read from a SQL database, if it's being written in Python or JavaScript. I don't have to know. And that's useful because then, and this comes to the uniform interface part, I can refer to that from any client, anywhere, and so long as I understand that contract, I can communicate with the web service. Stateless becomes important because when I commit an operation, when I try to get a resource or try to create a resource with that web service, I need to give it all of the information to complete that operation. Now, there's a burden there. That means that I need to be ready to give all of the necessary information each time. But it also means that I don't have to track prior interactions to know what's going on. And that's helpful because then I have less work as a client to do. I don't need to store state. And if you're not familiar with the concept of state, state is simply information being stored by a program. The less you have to manage state, the fewer bugs and the fewer uh, conflicts you have in your application. So how do you design a REST API? I'll stop for a second and say that we are taking questions. They will be relayed to me. If you have something that you want to know in the moment, let me know. Otherwise, we'll address things at the end. We'll open up some Q&A time. When we're designing a REST API, we need to think about the way the internet works. And forgive me if this is a rehearsal of any information for anyone, but it's helpful to understand some basics of HTTP, Hypertext Transfer Protocol. Everything that we do with the internet through HTTP involves a request and a response. And that request-response cycle makes up all of the interactions. Now, this is different for things like WebSockets, this is different for other protocols, but by and large, HTTP is what you'll be dealing with when you have a client and a web service. Why we care about that request-response cycle: when I make a request to a REST API, I'm referring to some resource or some action that I want to take, and that web service then is going to give me a response. It'll tell me, is it successful? Did it fail? Did I create new content? And if so, how do I refer to that content? Each request has a verb associated with it. These verbs are baked into the underlying structure of the internet. There are 8 or 9 of them, 4 of which we use commonly, 4 or 5 of which are used more for advanced operations, and we won't concern ourselves with those. These verbs are related to CRUD. CRUD is an acronym that we use when we're talking about databases, or really any kind of data store. There are 4 operations for any data set, and they are create, retrieve, update, and delete. I create a new record, I retrieve some information, I update an existing piece of information, or I delete that information altogether. And we can think roughly of the verbs that we care about for this purpose as related to that. These are not one-to-one mappings. These two technologies are not inextricably linked, but they're roughly equivalent when we're talking about how we want to design our REST API. Retrieve has the HTTP verb get. Post, we can use that verb to create a new resource. We can use put to update a resource that exists, and delete to remove an object. The other verbs are connect, head, options, patch, and I think there's one additional one that I'm forgetting now. It's an interesting subject, and I would encourage you to go research more about it. But again, for today's purposes, we're concerned with the most common: get, post, put, delete, and how they correspond to operations we do on data. Okay, so we have a question in chat. Why do we use post and put instead of create and update? The terms on the left side of those colons are the HTTP verbs. They are set. Those are standards that we use. I'm comparing them to create and update and retrieve and delete simply as terms. If you use something like get, you're creating an operation through HTTP. Does that make sense? Looks like it does. All right, so recapping, we get resources that exist, we can post a new resource, we can put an update to an existing resource, or we can delete an existing resource. Now those are requests. I request a get operation, I request a post operation, I request a put operation. In return, I get some information back. Every HTTP request and response has a method, get, post, put. It has a URL that we refer to, and then it has a payload of some sort made up of headers and a body. You don't need to know a lot about what's under the hood there just yet. Again, it's a fascinating subject. We're not concerned with it today. But when we get information back, we're getting back that same set of information, but instead of a method, we get a response code, a status code. You can see those at the bottom of the screen there. There are status codes from 100 to upper 500s. The ones that we're most concerned with today are the ones that are in the 200 range and the 400 range. Each of those sets of codes has a standard association, a standard meaning that people agree upon. Some people use them a little differently, but in general, things in the 200 range are successful operations. If I get back a 200 code of some sort, I know that something has gone right. If I get back a 400 code, I know that something has gone wrong. 200 in this case means success. 204 means successful creation without information coming back. 401 means you don't have the right to access that information. 404 means I couldn't find the information you're looking for. And one of my favorites, which proves that software engineers are very silly people, is 418, which says, I am a teapot. That comes from a long-standing joke in the internet. Uh, Way back when, on April 1st in 1997, somebody made a joke about having a coffee pot interface. Uh, don't, this being a lesson, don't ever take software engineering or software development too seriously. Those 200 and 400 codes, then, when we design a REST API, we want to know what I should send back. If I post a resource and then send back a 204 status code along with the response, I'm telling the client, you've successfully done a thing. You've successfully created a resource. And so that's how we communicate with the client that is accessing our resources. It's also important to think about entities. So now we know the basic call and response, request response cycle. Now, as I'm designing my REST API, I want to think about what information the client is accessing. So let's think about a taxi company. I'm creating a mobile app that I use to manage a fleet of taxis or a fleet of ride shares like Uber. If I am building a database or building a set of information, I might have entities like vehicles, trips, so individual point A to point B trips. We might have a record of customers. We'd certainly have a record of drivers. And we might also have a database of users. Those entities may exist somewhere in a database. They may be separate tables in some SQL or some document in a NoSQL database. And for each of those, we need to think about the data model that we've created. A vehicle might have an ID, a unique ID. We might store a vehicle make, so it's a Toyota. And we might store the driver ID associated with it, which could be some unique string is what I'm looking for, or it could be nil, it could be a null value. We think about those because those are going to determine later on what we communicate to the API and what we in turn communicate to the client. So now we know the entities and we know the operations we want to carry out. How does that help us define the contract between the client and server? Well, if we think about those entities and operations on a grid, we think about, hey, I want to get all of the vehicles in our service. So I might make a get call to the endpoint vehicles. Now, for each of these endpoints, I want you to think about some web address in front of them, www.taxiservice.com, for instance. And so each of these then is a path that we append to that. I reach out to the taxi service host, I append this path to that request and the information that goes along with it. So I want to get a list of all of the vehicles. I say slash vehicles. If I want to get a particular vehicle and I know its ID, I say hostname slash vehicle slash that ID. And those are get requests because I want to get information. I want to request information from the database. If I want to create a new driver, for instance, I might say taxiservice.com slash driver. That's not enough information on its own. When I send a post request, I'm also sending a payload. I'm sending a group of information or a structure, an information structure to that, and it creates a driver based on that, or a trip, or a vehicle, or a customer. So a request then might look like that post. We know the URL is some host slash driver. In that request body, we give it the information we care about, name, vehicle ID, vehicle make, whatever other information we've agreed upon. And the response to us might include things like a status code saying you've successfully created some information. Here's the ID of the new driver that you've just created so that later we can refer to it. When I make a get call again, then, if I were to use the new ID that's been created, so say when we create the driver Jacob, we get back the ID 15. Well, now my response body from that request is going to come back with the information associated with that record. So again, this is that request response cycle. I am giving the server or web service rather some information, and it is giving me a response based on that information. So the things then that we want to make apparent in the contract, status codes, we want to define very carefully the data that are involved in those payloads and whatever identifier we need to make the transaction happen. If I'm getting a list of things, I don't really need an ID, but I'm going to get back a set of IDs and a set of information. If I want to get a specific record or a specific entity, I need that ID, and maybe I need to include a payload. What are the crucial elements then in that contract? We name the endpoints so that the resource that the person, the client, is interacting with is clear. If we go back a couple of steps, I name the resource vehicle, the endpoint for the resource vehicle, vehicles or vehicle, drivers or driver, trips, customers. I want it to be readily apparent and human readable for the person that's relying on this resource. We use unique IDs to refer to individual entities. It's not really useful to me if when I call get and I give it the number 15, it's confused about which one those are. The same applies to different operations. So if I go to get vehicle ID 15, and later I want to update that record, those two should be the same ID. I should not be using different IDs for different operations. We want to align the operations with the relevant verbs. Now, some people will say that you can make a post request for anything, and technically you can do that depending on how your web service is set up. That's a bad idea though, because that post loses its meaning. I want to keep those aligned because these same operations that we're going through, the same changes that we're going through, should be aligned with that mental model of what's happening and what we're trying to do. Finally, when we're defining a contract, we want to set very clearly the information that we pass, the data that we receive, and the expected format for that. Or, if that operation isn't successful, what is the error code and the message we get back? So if I step back a second, you can see this notation here where on the line that says request body. That's JSON, much like me, JSON, JavaScript object notation. It is one way to refer to information. You don't have to use it. It's fairly common. You can use things like XML or you can use plain text if you like. It's up to what you define as the contract for your web service, but it has to be defined because if I can't rely on that contract, I can't reliably use that web service as a client. So now that we've talked a little bit about what makes an API design, how do you implement one? Well, there are as many ways out there as there are APIs. You can construct something out of a number of different technologies. The core is to pick the service that is right for it. I can host a web service on a server instance. Maybe it's on-prem, as they say, or on-premises. I have a physical computer next to me, and that's serving it. I can use a service like DigitalOcean or Laughing Squid and rent out a server that exists somewhere else. Or I can use a cloud service like AWS or Azure, both of which have services that are set up to streamline that process. And finally, we could just use a data store itself, like Google's Firebase. Google has another strong cloud offering, one of which is just a database that I communicate with directly. How you choose to implement that REST API is entirely independent from what your web client knows about it. And that harkens back to the point we made near the beginning, the part about being RESTful. One of the elements is that the client does not need to care what's under the hood. All right. If you are building an app, it is sometimes useful to ignore the details of a web service until later. When we are prototyping something out in the world, which means rapidly designing a basic concept without fully fleshing out all of the features, it might be useful to create a fake web service. There are tools like Swagger and Swagger Hub that can help you create an interface like a web service without actually doing any of the programming or the architecture behind it. Again, this is useful because when I'm working rapidly, when I need to move quickly and prove that a thing works, Or if I'm just excuse me, if I'm just focused on creating a user interface or user experience, I don't necessarily want that web service to take up my time. So sometimes that simulation is better for your process. Um, it's also useful to think about how much work you actually need to do yourself. I have built an API using Python and a framework called Flask, and that's fun and it's instructive. And sometimes, if I need to do very particular things with it, it's useful. Or if those are the resources I have at hand. But it's also good to know that AWS, Azure, Google Cloud, or IBM's Cloud offer ways to build that let you take out some of the development effort that you would otherwise put in. So the things I want you to take away from this, and I know I've blazed through a lot of this conversation, um, when you're designing a web service, really put some forethought into it. The more that you do your design work, your due diligence beforehand, the easier it will be to use, and ultimately, the easier it will be to develop. Understand the way that the web works. These verbs, status codes, there are standards out there for them. And there's a little bit of room to move in them. Some of them are a little bit open to interpretation. But at its core, these are the ways that we communicate. And as developers and as technologists, the way that we agree to interact with each other. Don't deviate from the contract that you establish. If you need to make a change to it, work with another team or the other person that's consuming it, and make sure that it's well recorded and well defined. Even if you're the web client and you're the web service, make sure that you understand what it is and that it's well set. Don't be afraid to use mock data when you're trying to develop rapidly. Sometimes the web service can wait, and be sure to use the right tool for the job. Don't think that you have to use a particular resource or a particular process. It's whatever works best for your project and your flow. We're going to post these slides later on. Some of the key, I'll get to the question that just came up in chat in a moment. Some of the key resources are Mozilla. The Mozilla Foundation is an open source software foundation that has done a lot of work on making the web usable, and they were one of the first players in the game. RESTfulapi.net is a pretty good resource on the in-depth questions about APIs. And of course, AWS is one of the leaders in the cloud industry, and they do a lot of good work explaining how to use cloud services. All right, so we have a question. Have you used Firebase? Is that good for making an API for my app? Kind of. There is no yes or no answer there. Firebase has a number of different components. And actually, I'm going to close this for a moment and we'll go take a look at Google Firebase. Cool. So Google has a number of different options in it. And these are some of the basic services that come with Firebase. Um, the short version is Firebase has a lot of different tools that can be applied to different circumstances. There are free tiers for it. I find Google's documentation to be okay. Some of these things are relatively new. There aren't a lot of tutorials or guides on it. But if you're doing things like communicating with a data store that doesn't need to be any fancier than just putting text fields in, real-time database is useful, or Cloud Firestore. If you are trying to do things with notifications for mobile applications or for web applications, or if you're trying to manage testing or different features on your app, can also be useful. I don't use it a lot. Our team uses it specifically for sending notifications and for managing configurations for an app. So I wish that I could say yes or no concretely. Um, the follow up to that question is talking about frameworks that I recommend for beginners. Um, Google and Azure have really cool features. They have really cool offerings. But AWS, Amazon Web Services, has been doing it for a lot longer. And I find that while some of the features can be confusing to navigate, their documentation tends to be better, and the offering that you get from a free tier tends to be a little bit more robust. Uh, If you are using AWS, there are a couple of different companies that teach about AWS, or their internal documentation exists and is pretty good. They also expose a lot of the documentation that they give to devs that are starting with them as well. And so you can see a lot of the products they offer here. I have personally used API Gateway. API Gateway is an easy way to define a quick and dirty REST API and hook it up to a database. So it's also really good for that initial stage where you're still just getting used to your app or starting to build the framework. Um, I will caution you to be careful about which services you use because you can quickly rack up a bill if you're not being aware of that. And of course, the constant disclaimer: if you are not of age, please make sure that you have an adult helping you sign up, because you are liable for the costs that you rack up, and that can get murky pretty quickly. All right, unless there are any other questions. Okay, unless there are any other questions, we're going to move on, and I will end this conversation. Please feel free to reach out. I am happy to participate in Code Day. I'm happy to talk more about this if you have specific questions about your apps. But in general, these are the things you want to think about when you're creating a REST API. And ultimately, it's on you to be a good developer, a good engineer, in communicating with other people and setting up these expectations. Happy coding, and thank you for joining me.